Several aspects of the game of volleyball involve physics, including displacement, velocity, and force. So for example, each of the 6 players on the court is assigned to a certain position, and although the players have a set spot, they move and adjust to the play of the ball. And so that the distance that they move to get to the ball is considered their displacement. Displacement being a change in position of an object, and it can be either positive or negative depending on what you consider positive and negative on the court. So me and Hallie are going to demonstrate passing. Okay, so when me and Haley are passing, the ball is coming off Hallie's platform, which is flat, so the direction of the ball is going to go up, and you could draw a force diagram for this. But okay, Haley, go ahead. Go ahead. Just pass the ball. You see how Haley's platform is straight, and so the ball is coming off of it, and then the gravity is pushing down on the ball, but the force of Haley's arms are bringing the ball upward. All right, so the next thing is serving, and serving, average velocity and average acceleration complement one another, and that's in all aspects of volleyball too. So average acceleration can be defined as the rate of change of velocity, and in volleyball, acceleration is used to find, it can be used to find the speed of a player whose velocity increases or decreases during a certain amount of time that she's in motion to get the ball. So not only do the players have acceleration, the ball obviously has acceleration as well. And then there are times in a volleyball game when the ball has constant acceleration, such as when the ball is served versus when the game is started out. As the ball's velocity increases, its distance also becomes greater in that time interval. So since it is in constant acceleration, the velocity increases by the same amount for each time interval. So when you serve the ball, you're supposed to follow through your arms. So I'm not going to serve because the ceiling's really low. But you want to give yourself a toss, and then when you hit the ball, you want to follow through with your
You
arm.
could probably serve.
Okay, whatever. So, if I were to just serve like this, the ball doesn't go anywhere because my arm is just stopping, and I'm not carrying through with my arm, therefore not helping force the ball. But if I follow through with my arm, the ball goes a much greater distance because of the force of my arm being greater. So now we're going to talk about hitting, which is like the biggest form of attack. So first let's look at the attack of the hit. Before you even start to hit, you have to read the set. So you have to read the trajectory, speed, and placement of the set, and that helps you determine when and how fast your approach should be. So if the setter sets the ball tighter to the net, you have to make a faster approach because you have less time interval to hit the ball. Whereas if she sets it outside the net or outside, you have a little bit more time to position yourself to hit the ball correctly so that it's most effective. So although you may not be aware of it, when you become more advanced, your brain begins to interpret these factors to help your timing without you even really knowing it. And by seeing the distance needed to be traveled and the velocity that the ball is traveling or how fast it's traveling, you can calculate a rough estimate of the time that you need to make your approach. And this is possible by the equation velocity equals distance divided by time. So another huge component of hitting is the energy that's involved in it. A lot of coaches advise you to plant and then take off quickly during an approach, and this is due to the concepts of kinetic and potential energy. During your approach, your ball has potential energy and kinetic energy. So the goal is to transfer your kinetic energy into potential energy. So when you're approaching, you're stepping fast, but then when you go to jump, you want to make yourself into potential energy so that you have time to hit the ball. So if you come to a stop during your approach, your kinetic energy is less, therefore you can't jump as high. So when you're making your approach, you want to be in constant motion. Since potential energy is a product of the mass of the player, gravity, and the height of the jump, the height is what determines how much potential energy will be attained. It's also important to remember that when you are hitting the ball, you want to transfer the maximum amount of momentum from your body into the ball. The more momentum you transfer into the ball, the harder the ball is hit. So momentum is equal to the force exerted on the ball multiplied by the time in which the force is exerted. So that basically means that the shorter amount of time your hand is in contact with the ball, the greater the force that is applied to the ball. Since the momentum from your body is greater than the force, it will also have to be greater if the time is short. So basically, the faster that you actually hit the ball and make contact with it, the harder the ball is going to be hit. So Sydney is going to hit for us with her left hand, okay?
Hold on, let me back up. Go that way.
So generally, you'll give yourself a toss and then step in and hit. So you see, when Sydney's hitting, she's starting with her left foot and transferring her weight into the hit, which is having the ball being hit harder because of the force of her arm is hitting the ball. And she's hitting the ball as fast as possible with her hand to make the hit harder. So yeah, that's it.
Hard as well.